Hi, I'm Dennis Frechette, and welcome back. Today I'm going to be reposting a video I did a few years ago. It's on a fireplace cook set. These are long-handled tools that were generally used over an open fire. So there's a spatula, a fork, and I have two different sizes of spoons. I've re-edited the video, combined all three videos into one, so hopefully that'll make it a little easier to watch. Hope you enjoy it. Today I'm going to show you how to forge a basic cooking fork. This is the long-handled fork that was part of the basic Colonial cookware set for cooking in front of a fireplace or over an open fire. I'm going to be using 3/8 square bar to make this fork. I use 3/8 a lot for this type of thing because it forges out just as easily as 3/8 round, but there's a surprising amount more material to work with. So it's great for projects like this where you have to move around a fair amount of metal. The first thing that I'm going to be doing is flattening out the bar slightly. I just want a little bit wider than thicker, and just gives me a better surface to start the split. And here I'm just using the last part of the heat to set up my chisel line. It's really important to take your time doing this split, because if it doesn't go straight down the center, then your tines are going to be misshapen and unequal lengths, and you're going to create a lot of work for yourself. So it really pays to take your time, make sure that it's as centered as you possibly can make it. Here I'm setting up a pair of dividers to measure the length of the cut. I'm not using the ruler directly just because I want to be working in the center of the anvil, and I find it easier to use dividers than trying to measure off the middle of the ruler. And then once I have the length marked out, I'm just going to reinforce the rest of the line so there's no question where the chisel's going when I'm ready to do the actual split. And again, this is a square face chisel, so I'm just driving it right through the work, right down to the anvil. There's no cutting edge on this chisel, so there's no way that it can damage the anvil. And then to finish the cut, you just use the chisel to shear out that thin slug that's left at the bottom of the split. Once the bar is split open, use the chisel to spread the tines out slightly and then forge them out so that they're roughly 90 degrees to each other. You don't need to spread them out any further at this point. Once you have the tines open to 90 degrees, check the inside edge of the cut. If it's really rough or ragged, then use a grinder or a file to clean up the sharp edges. If it's fairly regular, then you can forge out anything that's remaining so you can go ahead to the next heat. You just want to make sure that there aren't any ragged edges or sharp corners that can fold over on themselves and create a cold shut that could catch a cleaning rag or your hand later on. First thing you have to do when you're forging out the tines is to clean up that irregular cross section that was left from splitting the bar. So to do that, you have to stand that cross section up on that sharp edge and then drive it back into the main body of the bar. And then once that sharp edge is pushed back into the bar and you have a regular squarish shape, you can go ahead and round off the corners and start shaping the final dimensions of the tines. If you leave that sharp corner, the tines are going to have a tendency to twist on you because you don't have a good bearing surface for forging a clean edge, and that's going to make it a lot harder to get a nice looking fork. So you really have to get that shape into something that's roughly square, and then you can work from there and create whatever it is you're after. Now, this is the part of the process that isn't complicated, but it's really hard to explain, and you probably won't understand what I'm trying to tell you until you actually go out and try it. What I need to do is actually quite simple. I just want the tines to come out 90 degrees from the handle on each side of the handle. The problem is if I try to forge that T-shaped section by simply bending the tines around and hammering them back into the handle's actually going to cut off the tines because it's going to forge a very thin area right where the handle meets the tines. So what I'm doing here is not bending the tines, I'm actually forging them around that corner. I'm hammering right at the base of that V notch and forging the tines to go around the corner. The difference is the thickness of the material for the tines isn't changing. I'm actually creating a rounded corner at the base of the handle and the tines, and that's allowing it to maintain the same thickness right around the corner. So during this whole process, I'm not actually hammering the tines out. I'm concentrating on the base of that V notch, and I'm opening up that V into a straight section. And that's doing a combination of upsetting the bar and flaring the bar. And that's going to give me what I need to be able to forge a fork that has solid tines that aren't going to break. So again, it's not a complicated process. You just have to have a really good understanding of what you're doing and what you're trying to move, and then take a number of heats to get that shape right. It's not a quick process, but it really looks good when it's done. Now that I have the transitional area from the handle to the tines the way I want it, I'm going to take a few minutes to just draw out the tines and thin out the shape slightly. Here I'm creating a detail that was quite common with these forks. I'm hammering in an offset right behind the area where the tines meet the handle. That way when I shape the tines, it's going to look like it's one continuous bar that's just kind of stuck on the end of the handle. And then once I have that area established, I can finish squaring off the end of the bar. At this point, I'm going to take a break from forging the tines to finish the rest of the handle. There isn't really any point in finishing the fork off at this time because when I'm forging the handle, quite often the tines get whipped around and you have to come back and reshape them anyway. So right now I am just starting the initial shape of the tines, and that also gets them out of the way of the fire so I can get a good heat on the handle without burning the tines. So now I'm back working on the handle, and that pretty much involves just some pretty straightforward forging. Here I'm forging in a transition that I'm going to use to create a round bar section that was quite commonly inserted between the fork end of the tool and the actual handle end. In this example, you can see the advantage of forging this shape from a square bar rather than a flat bar. Here you can see that I have the round section forged to shape, but the flat section isn't forged yet. Because this started off as a square bar, there's very little difference between the size of the two shapes. So I can define the round section very easily without damaging the shoulders of that flat section because they're not there yet. So when I'm ready, all I need to do is forge out the mass of that square section into the flat section that I need, and the shoulders will naturally develop and transition into that round section of the handle. In this heat, I'm hammering in the offsets that are going to create the transition from the round bar back into the flat bar for the handle. And I'm going to be using the same technique that I just used to create the transition into the flat section for the fork. And then once I have that transition defined, I'm going to be able to go back and finish that round bar section between the fork end and the handle end. When you're forging a shape like this, it's important to keep track of where everything's going. It's pretty easy while you're hammering this round section to have the flat of the handle start veering off from the flat of the fork. So, you could have something that's maybe 30 degrees off or something. So you want to correct that before you do your final forging so it doesn't appear to have any kind of a twist in that shape. And here again, you can see how hammering that square section back into a flat section creates that subtle transition between the round and the flat. And in the flat section of the handle, it's just a matter of hammering the shape flat down in the center of the anvil. I'm not using the corner of the anvil here because I don't want the handle to get much longer. I want it to get wider, so I'm trying to minimize the amount that I'm drawing it down. I'm getting ready to cut the fork off of the main bar, and before I do, I'm going to finish shaping the actual fork, and that allows me to use the length of the bar as a pair of tongs, so it really simplifies the forging. And this part of the process isn't really very complicated, it's just a matter of hammering out the shape that looks good to you. I'm doing a more traditional shape here, but you can do whatever you like. Again, take your time and look at it from a lot of different angles to make sure the tines are even and well proportioned. So here I have the fork cut off of the bar and I'm ready to just forge out the rest of the handle. Again, I'm not getting too carried away here. It's just a pretty straightforward fork, two flat sections with a round in between and pretty straight lines, nothing really too elaborate going on. Last offset that I'm hammering in is going to transition the flat section of the handle into a rounded flat section that's going to have a hole punched in the middle of it. So this heat is basically just sectioning off the materials that I need for that. The end of the bar is going to be hammered out into a large flat washer shape, and to do that I need to get rid of the sharp corners on the bar so that it transitions more easily into that round disc shape. Once I have that preformed, I can go ahead and punch and drift the hole. I'm after a fairly large hole here, so I'm going to start by driving in a rectangular square-faced punch, and then I'm going to drift that hole round. Once I have the rectangular hole punched in, I'm going to be drifting it round. Now that I have the hole in place, I'm going to forge down the end of the bar to make a very even ring right around the whole cross section. Even if you take your time and do the best job that you can to get that hole right, there's always a little bit of extra material there that needs to be shaped out before you can continue. And I actually prefer that because if you try to cut it too close, it's very easy to create a thin area right there that's really hard to deal with. So I'd rather forge out the excess to where I want it. Here I'm just cleaning up the transition between the handle and the end of the bar. And then once I have that the way I want it, I'm going to flatten everything out to their final dimensions. And then the handle gets finished off by cleaning up any distortion that happened to the center of the hole from hammering that section flat. And as always, the final step of the process is just to go over everything and make sure it all lines up and looks good. Today I'm going to show you how to forge out the blade of a classic Colonial spatula. I'm only going to be doing the blade today because this is part of a 4-piece fireplace cookware set that I'm working on, and the handle is going to be identical to what I did for the basic fork video. The blade for the spatula is going to be made out of a 1/4 by 1.5 inch piece of flat bar, and I'm going to be welding that to a piece of 3/8 square bar, the same material that I used for the basic fork video. I'm going to be using a curved chisel to cut out notches on the sides of each bar, and that's just going to give me an area that I can transition into a scarf for the weld. If you don't feel confident about forge welding the handle to the blade, don't worry about it. You can just forge the handle with a flat spot and rivet the two pieces together. But the process of forging out the blade remains the same. Also, I'm using a curved chisel because I have it, and it does make a nicer transition into that scarf, but if you just want to use a straight chisel and cut 245s on each side of the bar, it wouldn't really affect the process that much. To join the blade to the handle, I'm going to be using what's called a cleft weld, and that's basically a weld where the handle material is split open and wrapped around the blade material. Basically the same way you would if you were to grab a piece of metal. Your thumb would be on one side and your fingers would be on the other. That's a cleft weld. So to set that up, I need to forge a very thin wedge-shaped transition on the end of this bar that's going to fit inside that forked piece that I'm going to be splitting out. It's kind of a weld that isn't used much today, but when you examine old ironwork, you see that it was really used quite extensively. And one of the reasons I like using it is because it just gives me a simple way of holding these two pieces together without riveting them together or without doing a drop tong weld where I have to take the two separate pieces out of the fire and join them up on the anvil. They stay as one piece in the fire, I pull them out, and they get welded as one piece without any complications. So here I've just been spending a few seconds trying to figure out how I'm going to lay this on the anvil in order to be able to cut this to length, which marking I'm going to use on this ruler. So I've decided to just position the top shoulder of the bar at the end of the ruler and then count back 4.5 inches, which puts the mark fairly close to the center of the anvil, which makes it easy to figure out. I'm placing a chalk mark on the metal because from here it's going back in the fire, and I want to make sure that that part is in the hottest spot of the fire. It'll be gone, of course, when I bring it back to the anvil. That's why I need the ruler to let me know where that mark is. Now I'm prepping the handle for the weld by forging a pretty blunt point to the bar. This is an optional part of the process. All this is doing is just pre-shaping the end of the bar so you have a little bit less forging to do when you have this cleft split open and you're refining the ends. As you'll see in a moment, this can easily all have been done as one process after I split it open, so it's up to you how you want to go about it. And you can see here how the two pieces are going to be fitted together. To finish setting up the weld, I need to forge the end of the handle tightly around the blade material. So I'm driving the blade back into the handle so it fits very tightly into the bottom of the notch, and then I'm going to forge the two sides of the split up against the blade so that it's as tight as possible. Here I'm driving the two pieces together, and the fork part of the handle is acting like an old style clothespin and holding everything together until I can get it into the fire. Now you have to understand that this clamping pressure that's holding the handle onto the blade right now is only there because everything is cold. Once I heat this up, I'm going to lose that and the pieces are going to fall apart. So once I get it into the fire, it stays there. I don't move it. So to apply the flux for the weld, I don't heat it up to a red heat. I just set this on top of the fire and let it heat up just enough to melt the flux. So it's still at a black heat. Everything's being held together as a unit and I can still move it around. Once the flux is hardened, that also helps to hold everything together. So at this point, I can shove it into the fire and get it ready for a welding heat. So it's a few minutes later, I have a welding heat, and now you finally get to see the point of all this. If I had to take these two separate pieces out of the fire and weld them conventionally by trying to lap them on the anvil, and doing a conventional, what's called a drop tong weld, I would probably have a 1 in 3 chance of getting it done. But because I'm using a cleft weld, I can do this and actually set the weld in the fire. And now I can take the piece out as a unit and go straight over to the anvil and finish the weld. I wouldn't normally be shaking it around like this. I'm just trying to show you that the piece is set and I can treat it as a unit and not have to worry about the two pieces falling apart. So by taking a little bit of extra time to set up the weld, I can increase my success rate dramatically for getting this weld together. And here you would just proceed as you normally would and use as many heats as you need to blend the two pieces together. Now I'm ready to start shaping the blade. The first thing that you need to do is create an offset that's going to divide the upper part of the blade from the lower section of the blade. This offset starts with a fairly sharp transition towards the handle end of the blade, and the blade portion is actually forged out into a wedge shape, which is later going to be forged into the blade of the spatula. So because I forged the stock out so that it has a section that has a full thickness piece of material followed by a thin piece of material that gradually goes back up into a full thickness piece of material, that is naturally just going to start giving me that keyhole shape when I start fullering it out. Now I'm ready to start fullering out the blade of the spatula. I want the handle material to gradually transition into the blade, so I'm going to stay away from this area and make sure that I don't create too sharp of a drop in thickness at that point. So I'm going to fuller everything around it and create the shape that way. So here I'm about 10 or 15 heats down the road, and I've substituted 45 minutes of hammering with about 5 minutes of grinding with the flap wheel to roughly define the shape. And now I'm going to be taking a series of very low temperature heats just to knock off the scale and put the final hammer texture onto the piece. So here's the finished spatula, and you would also use this same process for joining the handle to the blank that you would need to make a large ladle. Today I'm going to be forging the last two pieces to the fireplace cookware set that I'm working on, and they are two different sizes of spoons. The smaller spoon on the bottom is made from one piece, and the larger spoon on the top is made from two pieces welded together the same way I did the spatula in the last video. I'm going to start by forging the smaller spoon, and I'm going to be making that out of 3/8 square bar, which is the same material that I've been using for the handles. The spoon shape needs to get started in some kind of a hollow form. A lot of people use a wooden stump or a block that has a depression carved in it. I'm using this simple ring that's just welded to a bar that I'm going to place in the vise. So you can also use a pipe that has well-rounded edges. You just want to make sure that the shape doesn't have anything sharp on the back that's going to dig into the spoon, because that's really hard to deal with later on. The blank for the spoon gets shaped by tapering off the tip so that that part of the spoon doesn't spread out too much, and then creating an offset at the back end of the spoon towards the handle, again, so that area is thinner and there's less material to spread out into a spoon. So what you're left with is kind of a boat-shaped profile that has the mass of the metal in the center of the spoon where it needs to be the widest, and then it tapers off to the two ends. So when you start fullering this shape out, it's just naturally going to form into a large circular pad, and you're going to be left with very little filing or grinding to get the final spoon shape. And you can see I've left the top face full width because I'm going to need that later when I'm making the handle. When you're shaping the spoon blank, the hammer needs to be small enough to fit inside the form. If you use a hammer that's too large, the forming die is going to act like a bottom fuller and drive marks into the back of the spoon blank that are going to be hard to hammer out or grind out later. I'm just using this form to sink the spoon down to the depth that I want. The actual shaping is going to be done at the anvil. And then the final stages of shaping the spoon before I move on to the rest of the handle is just to take a few light heats and slowly go over the entire bowl of the spoon and knock off all the scale and replace it with a very fine hammer texture. The larger spoon is assembled the same way I did the spatula with a cleft weld, only this time I'm using 1/4 by 3/4 as the spoon blank. And again, I'm using the 3/8 square bar for the handle. Here I'm starting to rough in the scarf for the cleft weld that I'm going to be using to join the handle to the blank. Because there isn't really much of a difference in dimension between the bar that I'm using for the blank and the handle, I'm not going to notch out the corners like I did for the spatula. I'm just hammering them down and drawing them out into a thin wedge shape. The rest of this welding process is identical to what I described in the video when I was making the spatula for this set. The profile of the large spoon is going to be quite a bit different than I used for the small spoon. It isn't going to be round like a ladle, it's going to be more egg-shaped. However, the process of forging the blank is exactly the same. I'm going to be leaving the full thickness of the bar where I want the widest part of the spoon, and then I'm going to be tapering the blank down on either side of that to just about the final thickness that I want for the spoon. So that'll give me very limited stretch in those areas and the maximum width where I want the spoon to be the widest, and that'll just, again, naturally kind of hammer out into the profile that I want. You also have to keep in mind the final dimensions of the spoon that you're after. This blank might seem quite long right now, but once I start spreading it out into a spoon shape, you'll see that it's actually a fairly good proportion. When you're making a long, slender shape like this, it's pretty easy to underestimate the amount of length that you need to start with, and then that'll wind up in a short, stubby spoon instead of the shape that you're after. Of course, if you do overestimate and you make the spoon a little bit longer than you had intended, well, that's a lot easier to deal with than trying to stretch material that just isn't there. The process of forging the spoon is identical to what I used for the smaller spoon, only here I have a larger chain length that I'm working on. But again, the form is basically just used to get the depth of the depression that I want in the spoon, and the actual shaping of the spoon is done on the flat face of the anvil. And then once again, the final shaping of the spoon is done with a series of really low heats, barely at a red heat, and that's below the scale forming temperature. So what that's going to do is knock off all the scale and produce a very fine hammer texture on the inside and outside of the spoon form.